Good evening, learners. In today's class, we are going to see Unit 2 Production Planning and Control, Computerized Process Planning. In that, we are going to cover process planning, computer aided process planning, and logical steps in computer aided process planning. Process planning is identifying a plan in manufacturing a part or component from initial stage to final output. Process planning is also an important stage of product development because production tools like jigs fixtures can be identified only after a process is finalized. The process plan, which is done with aid of computers to manufacture a product, is called Computer Aided Process Planning (CAPP). The following are the activities of process planning from selection of processes and tool, selection of machine tools, manufacturing equipment, sequencing the operation, grouping of operation, selection of workpiece, holding device and datum surface, selection of inspection instruments, determination of production tolerances, determination of proper cutting conditions, determination of cutting times and non-machining times for each operation, editing the process sheets. So the information required for process planning is recorded in sheet which is called as process plan. The process plan is also called as operation sheet, route sheet or operation planning sheet. Here is an example of a plan sheet which refers part number, part name, operation number, operation details, machine, speed, feed, set, and output time. In early production system, a process plan is created by a process planner. For an efficient process planning, it requires experienced process planners. Because of the problems encountered with manual process planning, attempts have been made in recent years to capture the logic, judgment, and experience required for this important function and incorporate them into computer programs. Based on the features of the given part, the program automatically generates a sequence of manufacturing operation. The automated process planning provides opportunity to generate production routines which are rational, consistent, and perhaps even optimal. So these are the following advantages of process planning. It reduces the skill required of a planner, reduces the process planning time, reduces the process planning and manufacturing cost. It creates more consistent plans. It produces more accurate plan, and finally it increases productivity. So the approaches of computer-aided process planning is categorized into two groups as variant approach and generative approach. The structure of computer-aided process planning system is represented. It has totally 13 modules starting with the surface identification module, material selection module, process selection, machine selection, tool selection, fixture, end effector, process sequence, cutter path generation, intermediate surface generation, classification module, parameter selection module, and system maintenance module. So these modules are not necessarily arranged in proper sequence, but it can be based on importance or decision sequence. Each module here may require execution several times in order to obtain an optimal process plan. The input here is mostly a 3D wireframe or the solid model. in 2D or 3D form. The process plan, after generation and validation, can be routed directly to the production planning system. The geometrical model of the part is the input for the process planning system. The system outputs a process plan. So the input can be component drawing or the CAD model, whereas the other process planning inputs like part list, annual demand or batch size, accuracy and surface finish requirements, equipment details, data on cutting fluids, tools, jigs and fixtures, gauges, standard stock size, machining data, data on handling and setup. So these are the other prerequisites for process planning. In a computerized process planning system, a formal structure and a knowledge database are required in order to transform the engineering design information into a process plan. Operation of a typical computer-aided process planning software. Typical process planning software may provide the following basic functions such as process planning, initialization function, report generation. So in process planning, the modules like creating a new plan, retrieving a plan and editing it, deleting a plan, display a plan on monitor, and listing the summary informations can be done. Creating a new plan. Creating a new plan involves several stages. A figure represents a typical plan format. Here the user has to enter various data as per the format. Typical format is given in the table, which says a format of manufacturing sequence. Here all the manufacturing data are entered as operation number, machine number, and operation description, assembly instructions, manufacturing time, which involves step time and production time, and the standards, tools which we are using, cutting conditions, which includes RPM and feed rate, and finally the number of cuts. To retrieve a plan, it is given as in table. Process plan can be retrieved using any of the data field which is in its header format. A single field or a combination of fields may be necessary. Sometimes if we know a word in the description of a part, say serial number 1, and if you type 1, your plan which is stored in the serial number 1 can be easily retrieved. Summary information includes account information, machine information, material information, and so on. Process planning softwares have several modules as we have seen. One such module is automatic time standard systems. Here the input data will be material, material harness, work center number. The module then goes through the operation description, looking for work element, say a machining operation. It displays available tool materials like HSS, carbide, ceramic. It also calculates number of passes, displays recommend value, spindle speed, power required, and machining time. So these data can be edited if required. Similarly, there may be modules for time calculations, for loading and unloading. Report generation, computer-aided process planning softwares usually have SQL capabilities, which is structured query language. Here, reports can be compiled for paths with identified classification, paths with specific machine type, paths machined using specific tool materials and bill of materials. Group technology is an operation management philosophy based on recognition that similarities occur in design and manufacture of discrete parts. Similar parts can then be arranged into part families. To implement such a system, some form of classification of parts and coding is required. So a part family is nothing but a collection of parts which are similar either because of geometry and size, or similar processing steps are required in the manufacturing. Parts within a family are different, but the similarities are close enough in order to identify as member of the part family. Here, the general methods for solving these problems are mainly visual inspection, production flow analysis, part classification and coding system. So part classification coding system can be grouped into three types, like system based on part design attributes, system based on part manufacturing attributes, and the system based on both design and manufacturing attributes. System in the first category are useful for design retrieval and to promote design standardization. System in the second category are used for computer-aided process planning, tool design, and other production-related functions. So the third category represents an attempt to combine the functions and advantages of the other two systems into a single classification scheme. So the types of design and manufacturing attributes typically included in classification schemes can be the type of design and manufacturing attributes are classified. The part design attributes as basic shape, asymmetric, length to diameter ratio, material, major and minor dimensions, tolerance, surface finish. Whereas part manufacturing attributes includes major process of manufacturing, surface treatment, machine tool, cutting tools, operation sequence, production time, batch quantity, production rate, and fixtures needed. If we take a look at machine tool manufacturing industry, large part families can be grouped like heavy parts, shafts, spindles, non-rounds, gears, this type. From manufacturing point of view, group technology can bring in considerable economy in tooling, setup time, part changeover times, machine specifications. The classification of components in group can lead to formation of cells where similar components are machined. Here is an example for group technology layout. The left-hand side is a functional layout which includes lathe, milling, drilling, grinding, assembly, receiving and shipping process is done. Here the process is too clumsy, uh, whereas in group technology layout the process is done in sequence order. The process which are similar grouped together and arranged in a clear format. So here group technology is compared with the functional layout. Coding structures consist of symbols, which is used to identify the part or the manufacturing attributes. The symbols of the code can be like number, alphabets, or combination of both. Here, the three basic code structures for group technology is mentioned, like hierarchical, chain type, and combination of both. When selecting a coding system for a component representation, there are several factors to be considered, which includes geometry of a component, code structure, digital representation, and material of manufacture. Some of the coding systems that has been successfully implemented in process planning are given as OPIT system, code system, KK3 system, MI class system, D class system, and COFORM system. OPIT's classification system. OPIT's is a coding system which is used to identify the product's dimension, accuracy, material, original shape of raw material, and so on. OPIT is one of the widely used coding classification system to specify the design of product to manufacturing. So it has totally 14 digits and alphabets like 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D. 1, 2, 3, 4, 5 digits called as form code, which are used to identify the geometric data, and 6, 7, 8, 9, which is called a supplementary code. It is used to find the manufacturing data, and ABCD called as secondary code, which is used to get information related to the operation process. So digit 1 represents a part class. Here from 0 to 9, it is split as rotational and non-rotational part, where L by D refers to length to diameter ratio. In case the L by D ratio is from point 5 and till greater than 2, it comes under rotational, and L by D ratio, which is from 3 to 4, these are called as non-rotational. In digit 2, it represents the main shapes like external shape elements or main shape. And digit 3 represents rotational machining, where internal shape element, what kind of rotational machining is done, like main bore. In digit 4, plane surface machining is done, machining of plane surfaces. And digit 5 represents additional holes, teeth, and formings are indicated. In supplementary code 6789, so 6 represents dimension, 7 is a material, 8 is the original shape of the raw material, and 9 is accuracy. The form code for rotational parts in OPIT's coding system is given. So with this digit 1, 2, 3, 4, 5, we can easily pick the part class, external shape, or internal shape, uh, codes, along with the plane surface machining and auxiliary holes and gear teeth. We will consider an example. Here you could see the given part design. Form code is required to be drawn for the given diagram. Here calculate the overall length to Diameter ratio L by D. So the length of the figure is 40 and diameter is 25. So 40 divided by 25 will give you 1.6. When you go back to the previous slide and check in digit 1 part class, the L by D ratio is between 0.5 to 3. So our L by D ratio is 1.6. 1.6. So the digit is 1. First code of opets is going to be 1. Next, the part is stepped on both ends with screw thread on one end. So you have to study figure. Based on the figure, you can easily write the coding. So the second digit of the code could be 5. Well, you can check it with the form code table. And the third digit code is 1 because you have a through hole, and the fourth and fifth digits are both are zeros since no surface machining is required and there are no auxiliary holes or gear teeth on the part. The complete form code in opits is going to be 15100. To add a supplementary code, we would have properly code the sixth through 9 digits with data on dimensions, material, starting workpiece, shape and accuracy. So we'll go through other examples. A similar diagram is given. Here again length to diameter ratio are going to calculate and it is found to be 1.5. Again it is value between the range and so it is digit 1. So going back, it is stepped on both ends with screw thread on one end. Again it is going to be digit 2 is 5. Similarly internal shape. First we have seen external, next is the internal shape. So we are going to see in digit 3 form code, it is going to be 1. And plane surface machining it is not done. Similarly auxiliary holes are not done. So 0. Again our opits code is going to be 15100. Here is another example which is little more complex. The first thing we have to do is in opits calculate the length to diameter ratio. Next find the external shape, internal shape and surface machining. External groove is done. Auxiliary holes axial on pitch circle diameter. Here is another example. Without seeing the code, try to match with the answer. Calculate the length to diameter ratio. It is 1.52. Next, search for the external shape, internal shape, surface machining, and auxiliary holes. Here, auxiliary hole is there. So your opits coding is going to be 13033. Next is MI class system. MI class system it includes 12 digits, which is strain structure format. It includes digit 1 is main shape, digit 2 and 3 is shape elements, 4 is position of shape elements, 5 and 6 is main dimension, 7 is dimension ratio, 8 is auxiliary dimension, 9 and 10 is tolerance code, 11 and 12 is material tools. Benefits of group technology. Applying group technology in industries before and after is mentioned. So once after applying group technology, the flow becomes structured, retrieving paths can be possible, and the process is consistent, single, and best process plans can be achieved, regulated purchase of components, and the process is flexible. So the main benefits of group technologies are product engineering, manufacture engineering, production engineering, and production planning and control. And so other than this, other benefits like increased productivity, improved accuracy in estimation of cost, greater standardization and variety reduction, reduced setup times can be achieved, better product delivery, reduced cost of purchasing, improved plant efficiency can be possible. Overall, in today's session, we saw about the process planning, what is computer-aided process planning, and what are the codings, part families, part classification, what is the structure of the process plan, and what are the coding systems like OPID, semi-class, D-class. Here, based on the session, these are the questions which you can revise, like discuss the importance of process planning in product development, describe structure of a process plan, and what is the needs of a computer-aided process planning, what are its advantage, classify OPIDs and MI system. So try to recollect by viewing the previous slides accordingly, and always to remember these concepts related to a real-time product, so it will be easy for you to understand. In next class, we will be learning about the approaches of computer-aided process planning, like variant process planning, generative process planning, and totally integrated process planning, which is TIPS, TIPPS. So that's all.